Hi, in this video, we're going to learn about a few key differences in programming languages. Since the first computer program was developed by Ada Lovelace in 1843, there have been close to 9,000 different programming languages developed. You can imagine that some of the languages built 100 years ago probably aren't too helpful when programming the computers we currently use, and for this reason, only about 200 programming languages are in use around the world. Even though 200 is much less than the total 9,000 languages, 200 is still a lot of languages. Why do we have so many? Well, different languages have been developed to solve different problems. Not every computer or computer program is designed to solve the same problem, so languages have been created that will make solving certain types of problems easier. We have languages specifically designed to manipulate data, languages designed to make web pages more interactive, languages that help programmers develop apps, and so much more. Each language differs from others in many ways, but one thing most of the widely used programming languages of today have in common is that they are considered high-level languages. A computer programming language usually fits into the category of high-level or low-level. Let's look at some of the differences. In general, high-level languages are easier for people to understand. They use syntax or language closer to the way we have learned to communicate with one another, and in turn, make it easier to read and write programs. This also makes them easier to debug or find and fix errors in. On the other side, low-level languages are easier for machines or computers to understand. They use language that is closer to what the computer will understand and in turn don't take up as much memory or space. High-level languages can be run on any platform and are portable. The programs can be written and run without any knowledge of the hardware of the device running them, while in low-level languages, they are very dependent on the specific machine that is running the program. High-level languages need more time to execute commands because each part of the code must be translated before a computer can receive instructions in a way it understands. In low-level languages, less execution time is required because the program is written in a way that is much closer to the language the computer will be able to read. These are 4 of the most widely used programming languages, and they are all considered high-level languages. Though they each work differently and were developed for a different purpose, they all use commands and structures that are easier for humans to understand than computers. So what are some examples of a low-level language? Well, assembly code or assembly language is a language that uses terminology that is a bit closer to human communication while staying within a few steps of computer language. Just looking at this sample bit of code, you can imagine how difficult it would be to write a program using this language. And if this looks bad, imagine writing a program using machine language or machine code, which uses binary, which is composed solely of zeros and ones. If we were computers, we would see this bit of code and think, finally, something I understand. But as humans, this way of communicating seems as foreign as it gets. You can understand why programmers developed other languages to write computer programs. Another categorization we can use with programming languages is compiled versus interpreted. In a compiled language, the entire program is compiled or converted into machine code that the processor can execute before any lines of code are run. In an interpreted language, each line is read and converted one by one, right before it's run, rather than being compiled completely before any commands are executed. One pro of a compiled program is that after being compiled, any time the program is run in the future, it uses this already translated version, which allows programs to be faster and more efficient to execute than interpreted languages. For interpreted languages, because they are executed line by line, some lines of code can be run before an error is found. Let's take a look at all of the languages we've discussed so far and see how they fit into these categories. At the lowest level, we have machine language, or binary. This is the language that the computer understands and what all our programs are converted to eventually. Just a bit higher than this is assembly. This language is very close to machine code, so it does not take much to convert from assembly code to binary for the computer to understand. For this reason, this language is considered an assembled language, where a few things just need to be rearranged in order to allow the commands to be run. Now we get into our high-level languages. Of the four we've discussed, C++ would come first in our hierarchy because it is considered a compiled language. Next, we get to Java, which is a hybrid of a compiled and interpreted language because the program is compiled first, but the compiled version still needs an interpreter to run. The highest level of our hierarchy would hold interpreted languages, such as Python and JavaScript. Let's go.